morning. So we're going to go over proving parallelograms. So for this, of course, what we're going to do first is graph it. So I go over 1, 2, 3, 4, up 1, 2, and then over 1, 2, 3, 1, 2, 3 for B, and then for C we're at 2, negative 2, and then for D we're at 1, 1, 2, 3. Okay, and then we're just going to connect the vertices, the corners. Okay, so it says determine and give the most specific name for the shape for this one. So what I'm going to do, it looks like it is a rectangle. So what I'm going to have to do is I'm going to have to prove that using slope. So everybody remember slope is rise over run. Remember we talked about that. So it's going to be over, so 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Okay, and if you think about it, this is going downhill. Okay, so this is a negative slope. So I'll put it down here in different color, but we have AD, so slope of AD. Okay, remember it's going to be rise over run, and it's a negative, so it's negative 5 over 5, so that's going to be negative 1. We can check the same thing over here. So for parallel sides or parallel lines, have the same slope. It's spelled today. I'm thinking ahead of myself. Same slope. Okay, so I'm going to check that too. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So rise over run. So the slope of BC, and it's going downhill. We're going down, we're going down. Okay, so they have the same slope. Okay, so that means that the sides AD is parallel to the side BC. So those are definitely going to be sides that are parallel. So let's check another one. So if we look at this, okay, let's look at AB. So this one is positive. It's going up. So it's over 1, up 1, over 1, up 1. So remember, rise over run. So the slope of AB and also the slope of DC. So 1 over 1. Okay, so that means that AB is parallel to DC. Okay, so that means that they are parallel. Okay, so those are parallel. If we want to prove that it's a rectangle, so for perpendicular lines, this is going to help you when we do the proof. So this is why I'm going over this. So perpendicular sides or lines, okay, the slope, when you multiply those two slopes together, they should equal negative 1. Okay, remember we also said before that they were opposite. Okay, so opposite sign, either positive or negative. Reciprocal. Perpendicular. So reciprocal means we have to flip the fraction. Okay, so we have to flip that fraction. Okay, so opposite sign. So opposite, reciprocal, perpendicular. Okay, so we can check with this. So if we do 1 times negative 1, it is negative 1. Okay, so that means that AB is perpendicular to DA. Okay, and that BC is perpendicular to DC. Okay, so we have all those. So it is a rectangle. So the opposite sides are parallel. Opposite sides are parallel. and these are right angles. Okay, so they form right angles. Okay, so it says determine the quadrilateral given the most specific shape. So we'll go ahead and graph it. So it's at -2, 1, 2, 3, 4. And then 0, 1, 2, 3 for B. 0, 0 for C. -2 up 2 for D. Okay, so for me it looks like, okay, that this is probably going to be, so we can go ahead and figure it out. So one thing I'm going to do, so remember we have our distance formula, but we also have our Pythagorean theorem. So the sum of the squares of the legs is equal to the square of the hypotenuse. And I can use that right here. Do you see how that forms a right triangle? Same thing here. Okay, so we can check. So this would be, so the length of this side, so I'm trying to find this one. So it's up 1, 2, 1, 2. Okay, so I'm going to substitute that in. So I'm going to go 2 squared plus 2 squared is equal to c squared. I'm going to take the square root. So maybe we have to take that square root. Take the square root of both sides. Square root of c squared is going to be c. So 4 squared plus 4 squared, we take the square root of that. 4 plus 4 is 8. Square root of 8 is approximately 2 and 8/10. Okay, so this is for AC, or right here, which is, so it's going to be this one, so AD. And if you look, okay, it's going to be the same length for this one. Okay, so that means that those sides are congruent. So it could be an isosceles trapezoid. And then if we want to check if these sides are parallel, remember how we can do that? So we're going to use our slope, rise over 1, so 1 over 2. Same thing here. So this is over 1, 2, 3, 4, up 2. So our slope for DC, too much stuff on my table. Okay, so slope for DC is going to be rise over 1. Okay, it's going down, so it's a negative. So rise is 2 over 4. We can divide both of them by 2. It's a negative slope, so it's -1/2. Can check on the other side. So this is 2 over 1. So remember, rise over 1 for AB. It's a negative slope. It's going down, so it's -1/2. Okay, so they are congruent. Okay, so the two slopes are congruent. You see that? So they are congruent. So that means that DC, side DC is parallel to AB. Okay, so it's a trapezoid. Trapezoid has to have one pair of parallel sides. Okay, so it's an isosceles. Isosceles trapezoid strap. So I got this one. Okay, other side. So it says determine the quadrilateral given the most specific name. So you know what we're going to do. When in doubt, graph it out. So we're going to graph it. So we're going to graph it. And then I go over 1, down 1, 2. The next one is at -1. 1, 2, 3, 4, 5. Okay, now we graphed it. Okay, so we graphed them. Okay, so we can prove with the slopes that the opposite sides are parallel because it looks like it's a parallelogram. Okay, but we need to prove that they're parallel. So again, I'm going to use slope. So remember, we can do rise over run. So we're going to go over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so our slope seven. It's actually 7. It's going to be -7. This, everybody, so remember slope again is rise over run. So you want to graph these. Everybody use Desmos to help you graph these. So we're going to graph them. Okay, and then, so this is the slope for AD. Okay, and then we should get the same thing for this one. So over 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So 5. Okay. So our slope is going to be -7/5. Okay, so we got that one. The next one, I'm actually going to use the coordinates. Okay, so we have BA right here. Remember, we go left to right. So A is going to be first. So I'm going to label my points. Okay, so remember slope is the change in Y. So this is the slope for AB over the change in X. Okay, so I'm going to substitute in. So 5 minus 2 over -4 minus -6. Okay, so this is everybody where you'd want to do keep, change, change, keep, change, change. Okay, so 5 plus -2 is 3. -4 plus 6 is going to be 2. So our slope is 2/3 for that one. Okay, and then we're going to do the same thing for DC. Okay, so label the points, everybody. You'll want to do this in Algebra 2 next year. So same thing. So label the points. So -5 minus -2 over -1 minus 1. We're going to do keep, change, change, keep, change, change. It helps us keep track of this negative signs, everybody. Got to keep track of our signs. So now it's going to be -5 plus 2, which is -3. And then -1 plus -1 is -2. Negative divided by negative is going to be positive, so it's 3/2. The slopes are congruent. Okay, so notice the slopes. Okay, these slopes are the same. So that means that the side AB is parallel to the side DC. Okay, so it is a parallelogram. Opposite sides are parallel. Okay, we got this, everybody. Okay, and I'm going over this because you're going to need this to do our proofs. So that's why I'm doing this. Okay, we're going to go ahead and graph it. So I'm going to go -3, 1, 2, 3, up 1, and then over 2, up 1, 2, 3 for B. 1, 2, 3, up 1, over 1, down 1, 2, 3. Okay, so for this one, so we'll look at it. Okay, and I go, okay. I feel like I did the best with graphing it, but it's okay. So, so we look at it and we go, okay, we can say, okay, so we can check if the sides are parallel, okay, or incongruent. So remember, we can use this. So this is up 2 over 2, okay. So that means that we're going to use Pythagorean theorem, a squared plus b squared is equal to c squared. So I'm going to go 2 squared plus 2 squared is equal to c squared. 2 plus 2, 2 squared plus 2 squared is going to be 8. Square root of 8 is 2.8, okay, for c. Oh, you know what? I put this one in the wrong place. I was wondering that. I was like, it doesn't look like it's supposed to. Okay. Sorry, my bad. Let me change that. Okay, so now it would be 1, 2, 3, 4. Apologize, everybody. Let's redo this. So it's going to be 4 squared plus 2 squared. 4 squared is 16 plus 4. Okay, so that's going to be square root of 20. And we can check that on all the sides. So again, everybody, it should be right down here. Okay, this is the same thing, 4 over 2. Same thing with this, so it's 2 over 4. And same for this part, 2 over 4. Okay, so that means that all of them are congruent, so all the sides are congruent. Let's double check this. All right, square root of 20. Okay, so we got this one. So it's going to be approximately like 4.4 or 4.5. So all these sides are congruent. Okay, and then what we also have to check is the slopes. Okay, so slope of AB, so this is 4 over 2. Remember, it's rise over run. So 4 over 2. Same for this one, so it's going downhill, so it's 4 over 2. So it's going to be negative 2. Okay, so that is going to be the slope of DC and also the slope of AB. So that means that these are parallel. And then we look at the slopes over here. So the slope for this one, for AD, and for CB. So that is going to be, so rise, so up 2 over 4. So 2 over 4, which simplifies to 1/2. Okay. Oh, these are going uphill. It's going downhill. Okay, so I'm trying to look at this and do all this stuff at the same time. Okay, so this means, everybody, that their opposite sides are parallel. They're also congruent. So that means that this is a square. Okay, good luck, everybody. You got this.